is the screencast for section 10.2, example 1. We're going to start with a review of vectors and then move into the calculus part of vectors. So we have two-dimensional vectors here. If you remember, a vector is an ordered pair of real numbers. It has component form, those little brackety things right there. And the numbers a and b are components of the vector. So a is like an x component and b is a y component. It starts usually at the origin, and then that has magnitude and direction. So if you have a vector that doesn't start at the origin, its initial point is not at the origin, you can take the head minus the tail. So the x2 minus x1 and then comma y2 minus y1, and that will get you the coordinates of what it would be if it were starting at the origin. So in example 1, we're going to find the magnitude and direction of the angle theta of the vector v, which equals -1 comma square root 3, and that's drawn right here. So we have the vector that starts at the origin and then goes out to the point -1 comma square root 3. Now the magnitude, or absolute value of the vector, is the non-negative real number, so the absolute value of a comma b. It's basically the length of the vector, which is why it's square root of a squared plus b squared. So let's find the magnitude. The magnitude of v, or absolute value of v, is going to be the square root of, now in our case, I know it's a squared plus b squared, but I wanted to show you it's, the distance, the x distance squared plus the y distance squared, and then you take the square root of that, which gets you the square root of 1 plus 3, the a squared plus b squared, and then 2. So the magnitude is 2. The length of this vector is 2. Now as far as the direction angle of the vector, well, we have theta here, but we can use a reference angle to help us with that. So I'm going to draw the angle with the negative x-axis in our vector, with theta in the middle. And I'm going to use a perpendicular down to the x-axis as a reference triangle, set up my triangle. Pythagorean theorem gives me the hypotenuse, so I get that this distance is 2. So that angle then, right there, the sine of theta is the square root 3 over 2. However, that is in quadrant 2, so it's not going to be pi over 3, it's going to be 2 pi over 3. Then now try problem number 5 says find the magnitude of the vector and the direction angle theta it forms with the positive x-axis. And theta has to be between 0 and 360 degrees. Alright, so first I draw out my vector 2, 2. So that's the vector that starts at the origin and ends at the point 2, 2. If I'm going to find the magnitude, I'm going to look at the square root of a squared plus b squared, and then that's 2 plus 2 squared, which again I did the -0 because in case you have a vector that doesn't start at the origin. And that's square root of 8, which is 2 square root 2. So the magnitude of our vector, the length, is 2 square root 2. Now what about the direction? Well, I'm going to draw a perpendicular down to the x-axis, use that reference triangle. I'm trying to find theta for the direction. There's a height of 2 and a width of 2 on this triangle, so the two legs are 2, which means I could take the inverse tangent of 2 over 2, or the inverse tangent of 1, which is in fact 45 degrees, or pi over 4, but they gave us degrees in the original problem, so we'll use 45 degrees. So the magnitude's 2 square root 2, and theta is 45.